Good evening. I am going to present a walkthrough of this puzzle by request. The puzzle is called Parity Party 20, and it carries the nickname Crescendo because it is a hybrid of Parity Party and Rossini Sudoku. Both rules are, they have a long history, although Rossini has a slightly longer history. Parity Party is a constraint that I invented and am very pleased with, and I'm always hoping that more people will use it. But I've had fairly little success getting it to really catch on, which is fine. The future is long, and we have it all ahead of us. The entire future is ahead of us, so that's pretty significant. I'm going to go ahead and explain the rules, and then I'm going to do a simple walkthrough of the puzzle. I'll start with the Rossini portion because Rossini Sudoku is the slightly more familiar and also a fairly simple set of rules. Rossini simply means that the little arrows that you see in the puzzle, and here I'm going to go to the solver, and the little arrows you see indicate that the first three digits in that area are increasing in the direction of the arrow. So if the arrow is pointing away from the grid, then the increase is going outward. So you can kind of think of them as little thermometers. So there's a thermometer headed this way. And if the arrow is pointing into the grid, then the thermometer is heading inward. And I'm just going to go ahead and show you in a box with several arrows how that ends up working. This digit is smaller than these two, and it's also smaller than these two. Meanwhile, this digit is bigger than these two, but it's also bigger than these two because of the arrows. For Rossini Sudoku, as is traditional, a negative constraint also applies. That's the usual way it's done. It doesn't have to be done that way, but it is traditional. And that is to say that if no arrow is given, such as in these three cells, that means that they may not exhibit a steady increase in one direction or the other. So those digits can either have the largest digit in the middle, or they can have the smallest digit in the middle, like so. Okay, so the negative constraint applies. Now, as it happens in this puzzle, the negative constraint also applies here where you see the parity party clues. All these numbers are parity party clues because those numbers are not, they don't have arrows on them or next to them or on top of them. Not only does a number indicate a parity party clue for that row or column, but it also essentially indicates that the anti-Rossini constraint is in effect. And that's going to be useful several times in this puzzle. So let's talk about what parity party means, but first let's get rid of all of these thermometers. I'm just going to reload the page. Okay, so if you see a number on the edge of the grid, that is referring to the sum of the first unknown number of digits. It's the sum of all of the digits up to and including the first odd or first even digit. Okay, so if this 23 clue starts with an odd number, say 7, then it's going to be the sum of all the odd numbers you see up until you see an even number. So, for example, the 7 could be followed by a 3, and a 9 makes what, 19? And then a 4. And that 4 would say, okay, stop counting here, and that's your sum. So that's an example of a good fulfillment, or of a valid fulfillment of that 23 clue. And notice that I have the anti-Rossini thing happening. The lowest digit is in the middle. And the highest digit could have also been in the middle. So there's another valid one. Okay, but if it, instead of starting with an odd number, if it started with an even number, say it started with 8, and then it went 2 and 4, well, then you have a total of 14 so far, and this could be a 9. Or I could actually have a 6 here, and then we'd end with a 3. And that would be a valid fulfillment of the 23 clue. So as you can see, in this particular case, 23 can be 5 digits. It can't be 6 digits, though, because in order to be 6 digits, it would have to be 5 of one parity and the 6th digit of the other parity. And the only way these 5 can be the same parity is if they're odd. And 1, 3, 5, 7, and 9 add up to 25. So a 23 clue will never be 6 digits. What's the minimum that a 23 clue can be? These are the kinds of questions that are really useful in parity party. A 23 clue can certainly be 4 digits. We just had an example of that starting with odds, and we had one starting with evens. But it could be as few as 3 digits if you choose your digits carefully. Remember that 23, for example, in 3 digits would be 6, 8, and 9. Well, in order to arrange that, the 9 would have to be at the end, and then the 8 and the 6 would have to be here. Okay. And you can see right away, of course, that the 9 can't be here, and this is never going to be 3 digits, but we're getting ahead of ourselves. But theoretically, that can be as few as 3 digits. Now, 11, for example, can be as few as 2 digits because it's just one odd number, and then you stop on the even number because that's the change of parity. And vice versa is also true. If you start on even, you can end on odd like this, or you can have one more even and end on odd like this. So, FYI, 11 is either 2 digits or 3 digits, or it can be up to 4 digits. So this might be 3 odds, say 1, 3, and 5, ending on a 2. Okay. So you get more familiar with sort of the potential size of these things as you go along. The last thing to know about parity party is that, I'm going to repeat the rule, you're adding all the digits up to and including the first odd, or the first even. The corollary of that you might not expect is that if you get a 1-digit clue, like this 8 here, then it might just very well be the first digit. In other words, 0 odd numbers plus an even number. But the 8 doesn't have to be just an 8. It can also be something like 1 and 3, followed by a 4. Whoops. Or it can be 5 and 1, followed by a 2. That would be both would be valid fulfillments of this clue. Okay. And in fact, so one of the things you're going to see in this particular puzzle, where the Rossini and parity party clues combine, is one of the features of this puzzle is that we're kind of going to move around the corners, the corner boxes, during the solve, and the sort of the middle cross here, where the least number of clues is present, is going to be sort of saved for the end, more or less. So that's just a little taste of what's going to happen. And in fact, we're going to start with these 2 rightmost clues where I've given all the examples. And you'll notice, if you do the Rossini work, I'm not going to draw in the thermometers because I don't really find them very helpful. You'll see that all of these digits, all of the cells that I've just highlighted here, are affected by the Rossini constraint. And you'll find that this digit and this digit are the sort of origins of a sort of chain of thermometers. And you'll recognize that the 8 clue, which looks like the least sort of the most restricted clue in here, you'll very quickly be able to conclude that it must be a single digit. It must be just the 8 here. because if it's going to be, it's never going to be 2 digits because they would be different parities and that would therefore be an odd number. They must be 3 digits or 1 digit. And if they're 3 digits, then it's 2 odds and an even. It can never be 2 evens and an odd because that would also sum up to an odd digit, an 8. The 8 is even. So we're going to have to end with an even digit. That even digit is going to be less than 8, obviously. So it can be 2, 4, and 6. You can eliminate 6 because in order to get to 6, these two will have to both be 1. Yeah. So it's either 1 and 3 in some combination followed by 4, or it's 1 and 5 in some combination followed by 2. And as it turns out, this number, as we see, we can both 2 and 4 are not viable as candidates for that cell because there have to be 1, 2, 3 digits smaller, but that 1, 2, 3, this digit also has to be larger than this one. All of these digits have to be smaller than this one. And since this can't be 2 or 4, we know that the 8 clue has to be fulfilled by a single digit. Okay. And this digit, because of what we just said, has to be at least 5. So, wait, sorry, not quite. I forgot. This digit is also smaller, right? So this digit, this must be at least a 6. And it can't be an 8 anymore. And that's our first conclusion that we can draw about this end of the box. 8 is even, and I'm going to color all of the even digits green. Okay, and now we're actually going to go to the 23 clue that we've already talked about so much. And we're going to ask ourselves, we already know it can't be 6 digits. We talked about that, but we also now see that it can't. We also know that it can't be 3 for 2 reasons. First of all, this would have to be a 9, and it's the beginning of a thermometer, if you will, or the beginning of a Rossini series. But it also 6, 8, and 9 simply it has an 8 in it, and you're dead. If this isn't 6 digits, it's also not 5 digits, because in order to be 5 digits, it can't be 4 odds and an even, because that would be an even number. And it can't be 4 evens and an odd, because those 4 evens would have to be 2, 4, 6, and 8. And although those can be added to a 3 to get 23, there's already an 8 in the column. So we definitely have a 4-digit 23, and it's 3 digits of one parity and 1 digit of the other. Okay. So there is only one way to do that with evens and an odd, right? And that would be these being 2, 4, and 6, and this being a 9. Whoopsie. 9. So that's a very, I don't think you have to work very hard to realize that with only one possibility starting on evens, that there are many possibilities starting on odd, right? So it makes sense to first try to eliminate this 2, 4, 6, and 9 combination. And this is, I think, probably one of the harder steps to do, but I also think it's unavoidable. It's like pretty clear that you want to clarify what's going on in this box first, because of this large clue and because of, I think, the 11 being a fairly small clue. So let's go ahead and do that and try to eliminate all of these possibilities that's being some combination of 2, 4, and 6. Well, we know it's not a 6 because, again, just like we did in box 9, we can see that all of these 4 digits, and in fact this digit as well, all of these 5 digits have to be larger than the 4. Larger than this one. Let's color this one to mark it. So the 6, this can't be 7. These can't all be 7, 8, and 9. And in fact, if it's 4, right, if we make, whoops, if we try to make this a 4, then this digit here, you know, the largest it can be is 6, and then these two digits would have to be between 4 and 6, and that is pretty yucky. It's not going to work. So the last option is that this is a 2, and this is some combination of 4 and 6. And that's, as it turns out, also not going to work, but that's for a new reason, namely, what that actually does is because all of these numbers are larger than 2, we know that the number 1 is going to be in these two cells. And there's a problem trying to fit a 1 into the 11 parity party, because if one of these numbers is a 1, the other number is also going to be odd, right? So I can't start with an even number and end on 1, because there's no way that's like the largest even number I have is 8. If I have 8 and 1, that's only going to be 9, and I'm done, right? So the only way to put a 1 into one of these two squares is if this whole thing was 3 odd numbers ending on an even. And that looks like it could work, but this is not a 1. But the problem with that is, from the 2, this can't be a 3, because I can't get across here fast enough to, there's no number between 2 and 3. And if it was a 5, these two numbers are 1 and 3, and now I don't have a number here because 4 is taken and 3 is taken as well. So there's no way to satisfy this Rossini constraint with the 1, 3, and 5. Okay, so that's the tricky spot for this puzzle. And now we can finally conclude that these 3 digits are definitely odd, and I'm going to use orange for odd and green for even. Greven. Okay, so this is now a 2, 4, or 6, and these numbers are odd. Okay. If this was 2, these odd numbers would be adding up to 21. And the only way to make 21 with 3 odd numbers is 9, 7, and 5. Whoops. The only way to make 21 with 3 odds is 9, 7, and 5. And this can't be a 5. In fact, it can't be a 4 either, as we haven't really proven that it can't be a 4 in this context. But it can't be a 5, especially because 7 and 9 are already in here. So this digit, I'm going to go ahead and, first of all, I'm going to take 2 out of here. But if this was a 4, we'd still have, instead of 975, 975, we'd have 973 here. 19 plus 4 is 23. But even here, with this being a 3, whoops, if this was a 3, all of these digits have to be larger than 3. All of them have to be larger than 3. This is already larger than 3. So these two numbers are 1 and 2. And that's hopeless. Okay? So this can't be a 4. Whoops. Cannot be a 4. We already know it's going to have to be a 6. But now we have 2 options here. This can either be 1, 7, and 9, or it can be 3, 5, and 9. Okay? 3, 5, and 9 is going to be problematic as well, because again, both of these numbers are larger than 3. The 1 and 2 get shunted off into the corner here. And of course this can't be a 9. And as we already seen, it can't be a 5 no matter what you do. So, long story short, these digits are going to have to be 1, 7, and 9. And since 7 and 9 both can't be here, this is definitely a 1. These can't be in the wrong order. They have to have the largest or smallest digit in the middle. The smallest digit's already taken, so this is the correct order for the 7, 9, and 1 series. And that means that all of these cells are going to be larger than 1, which is not a tall order. It's not going to be hard to do. As nice as it would be to resolve that quickly, we can't really make any progress anymore. And in fact, in this box, there really isn't a whole lot more we can do. We could try out things and say, is this a 2? Well, then this would be maybe 3 and 8. Who knows? But we have, I think, a fairly long road ahead here. And I'm not going to really explore it, and rather I'm going to jump over to this square, to box 1, and think a little bit about what we can do here. There is no 1 in this row. And if you look at the Rossini constraint, you can also say there's no 1 in this row, because this digit, in order to be a 1, this would have to be a 0, because it's in this column, and of course all of these digits are even larger than this one. This digit is at least a 3, right? And this can't be a 1. So in fact, the 1 is up here in the 21's clue, and it's going to have to be accompanied by another even number, right? Excuse me, it's going to have to be accompanied by another odd number. And in fact, 2 odd numbers make an even, so I can't stop here with an even, because then I'd have an even total. So this is also going to have to be odd. And again, if I put another odd, I'm going to have an even number, and this would make things, if I add another odd, I'm going to have an even total. And if I add yet another odd, I'm going to have 25, and everything is disastrous. So this is going to be a 4-digit 21 clue. It's going to include a 1. It's not going to include a 7. So this is some combination of 1, 3, 5, and 9. 1, 3, and 5 makes 9 only. So this digit would be way too small. So this definitely has a 9 in it as well. Just say shift 9 here. This is also shift 9. Come on. Okay. So there's definitely a 9 in here, and the only question that remains is whether there's a 3 going with it or a 5 going with it. 1 plus 3 plus 9 is 13, so this would be an 8. 1 plus 5 plus 9, make this a 6. Okay. The other thing we'll have to notice, and this also is critical, is once we figured out where the 1 is in this box, the next question that is fruitful to ask is, where does 2 go in this box? And as it turns out, 2, this might be a 2, but all of these digits would be larger than it. And obviously if it's 3, then these also can't be 2's. So there's no 2 in this row. Obviously these are all odd numbers. So the 2 is going to be on the 21 on this bottom row of the tier. And if there's 1, 2 in here, it's not going to be at the end of a series of evens. At the end of a series of odds. These 2 odds, even if I could use a 9, would add up to 16 at most, and 16 plus 2 is only 18. Long story short, not only is this is the 2 down here, but all of these digits have got to be even. So 2 plus 4 plus 6 is 12. That's the minimum. 2 plus 4 plus 8. 2 plus 6 plus 8. All of those are options. 2 plus 4 plus 6 makes this a 9. It can be a 7. It can be a 5. It can't be any smaller. It can't be 3, for example, because I can't make this into 4, 6, and 8. I can't make this into 18 because I can't get rid of the 2. So this is definitely 5, 7, or 9, and it is definitely odd. Okay. Oh, by the way, this can't be a 1. If this is a 2, this can't be a 3, so this is definitely at least a 5 or a 9. And in addition to the 2, I'm going to have a 4, 6, or 8 somewhere here. We can certainly say that this number cannot be an 8 because it has to have, like I said, 1, 2, 3, 4 digits larger than it. It can't be a 6 either for the same reason. So this is either going to be 2 or 4. If it's a 4, things get a little bit iffy, but I'm not sure I'm going to be able to prove that that's a problem. Right? Yeah, I might leave that because I kind of don't want to deal with it right now. Let's see. 4 would make this either 2, 6 or 2, 8. So there's at least one digit larger than 2 in here. This certainly can't be a 5. So this would be 9. Let me just take a look at this because I'm not completely remembering. If this was 4, this would have a larger digit. If this is 1 and 3, then this immediately has to be a 5. 5. I have to have an 8 in this spot. No, I don't. If I'm making this 1 and 3 just so I have as much flexibility as possible, 6 and 7. But then here I have 2 and 8. Yeah, it looks like this could work. This could work. So I'm going to go ahead and say I can't yet make progress with the two, with whether that's a 2 or a 4. But you know, feel free to correct me if I'm wrong. 3, 1, 9. Yeah, I don't know yet. Okay, so let's come back to this box because with the 2's in here, I know that this can't immediately be a 2, right? And if it's not a 2, and certainly none of these can be 2's, the 11 clue has to have a 2 on it. And 2 in a parity party clue is either going to be accompanied by a 9, and that makes this a 2 cell 11. It's not possible because 9 is already in the box. So that 2 is either going to be part of a series going 2, 6, and 3. Sorry, I'll just take out the 3 here, and ending on a 3, or it's a 2 and 4, ending in 5. Now I think you can quickly see that 2, 6, 3 isn't going to work, because if this is a 3, then this Rossini clue is going to have a 2 in this spot, and we've already got a 2 in the box. So this must be a 5. These two can't be 2 and 6. They have to be 2 and 4. They can't be steadily increasing, so this is 4, this is 2, and this can be anything. But in fact, we're done with the box, aren't we? Because these numbers, what's left here is 3, 6, and 8, and they have to be increasing in the direction of the arrow. So 3, 6, 8. All right. Now, that helps us here because this can't be an 8 anymore. This is in fact a 6. And these two are not... oh wait, let me take this out again because we're not sure if it's a 9. These in any case are 1, 5, and 9. These two digits are 2 and 3. This is no longer a 5, so that's convenient because that means, let's see, 2, 6, and 8 with a 9, or 2, 4, and 8 with a 7. Is that right? 14 plus 7, or 16, or 13 plus 9. No. Being stupid. 12 plus 9, 6, 4, 2 plus 9, or 8, 4, 2 plus 7. Okay. Blah, blah. What have we eliminated? 8, 4, 2 was 8. Oh, so I guess we know that there's an 8, there's a thingamajig. We know that there's a 4 on here. 2, 4, 6, 9, 2, 4, 8, 7. Yeah, there's definitely a 4 on here. And that has the corollary that there's wait, oh no, I'm being stupid. By Sudoku, I know that there's a 6 down here. So this is either 2, 4, and 6, or 2, 6, and 8. But 2, 6, and 8 is 2, 6, and 8 is 16, and this would have to be a 5. 5 is already there. So long story short, this is 2, 4, and 6. This has to be a 9, and this is 7 and 8. Okay. Now, we already know this can't be a 6. And then the question becomes whether it can be a 4, 2, but 2, 4, and 6 are definitely in here. These 3 digits are increasing in this direction, and all the numbers that are left are 3, 7, and 8, right? And so we have to go 3, 7, and 8, and this number has to be less than 3, so it's 2. These numbers cannot decrease or increase linearly, so this is 4, this is 6. Similarly, these can't increase or decrease linearly, but we don't know anything about them. The 1 can be in the middle, or the 9 can be in the middle, but it certainly can't be a 5. Whoop-de-doo. It doesn't tell us much, but it's something. Okay, so we're largely done with boxes 1 and 3. In the middle, in box 2, there's not a whole lot to do, but I can say one thing, which is that in column 5 of this box, these 2 numbers are the small, and these 2 numbers are the large. The number that in between has to be either larger than both or smaller than both. But 7 and 8 and 2 and 3 being taken, this would, to be larger than both, it would have to be a 9. There's already a 9 there. So this actually has to be less than 2 and 3, so it must be a 1. It can't be a 2, obviously, etc. So that's a nice little thing. It doesn't help us a whole lot, but it's kind of funny, I think. 6, 2, 3, 1, 7, 8, 9. These 2 numbers are 4 and 5. Okay. Now that's definitely a crescendo no matter what we do, and this is definitely non-Rossini no matter what we do. So we can't disambiguate those any further. Okay. And now we're going to take this box and we're going to come down to box 9 again, which is where we had started, kind of bouncing around the corners of the box, of the grid. Here we can start kind of narrowing down this digit, I think. First of all, the digits that are left over here are 2, 3, 4, and 5. And we have a 19 parity party clue to fulfill, but we don't really know how to fulfill it, and I just realized I want to go ahead and color these before I forget. Well, I did forget, let's be honest. And there you go. With the 8 is already in this box. Can this digit be a 5? Well, it can't be because all of these digits are larger than that digit. So we can already eliminate 5 from here. Can we eliminate 4? Well, we've got 5, 6, 7, 8 being smaller, being larger than it. Well, the 8 is already thing, but this would be 5, 6, 7, and 9. And that in and of itself I don't think is a big problem. For this would have to be 5, I think. Yeah, I'm using up all of the digits larger than 4. Let's see, 4. Oh, come on. Read my mind. 4, 5. This obviously can't be a 6, but the 6 would have to be right here. But this can be 7 and 9. This can be 7 and 9. So it's not. We can't exclude 4, at least not right away. But we can exclude 5. Whoop-de-doo. Can we exclude 6 from here? That's actually a good question. Notice that 6 is actually ruled out from those cells. So this so it's definitely a 6 in one of these squares, but it's not clear which. Can this be a 6? Well, in order to accommodate it, this would have to be a 2, which is possible. This number is definitely between 2 and 6. These 2 numbers are definitely between 2 and 6, so it could barely work, but this, notice, can't be a 3, so this would have to be 3, this would have to be 4, and this would have to be 5, and that breaks. So we can whittle this down a little bit. This is definitely not a 6. One of these two digits is definitely a 6. But this one is not. So this is either 7 or 9. That's nice to know. Not necessarily helpful. Let's restore these. This was possibly 2, 3, or 4. And this 2, 3, 4, or 5. Yeah. Wait, one thing I did notice before we get too far into it, this can't be a 2 because then I don't have a crescendo into here. 2 would be too big. And similarly, notice that 8s are excluded from these cells, so I'm going to pencil mark an 8 here. It's small beans, small potatoes, I should say, small beans. But I'm just writing it in there. So we've excluded 6 from here, but we can't really exclude 7. We're going to look at this this 19 clue at least a little bit, and try to figure out whether this 6 can be eliminated from here. In order to eliminate 6, I have to recognize that these two numbers, they can't add up to an odd number. It's finish on 6, so they would have to both also be even. In order for both of them also to be even, they'd have to be 2 and 4. This would have to be 3, and then 2, 4, 6. This would be a 7. It doesn't look like that breaks, to me at least. No, actually it does, doesn't it? This can't be 2 or 4 because there has to be a crescendo here. This number is at least 4 already, and this number has to be larger than it. Sorry, I didn't notice that. So I think it's safe to say, with the 8 already being here, that this cannot be a 6. Whoops. And in fact, you'll find this isn't 6, this isn't 6. This number has to be a 6. Okay, this is 7 or 9. Without the 6 in there, let's make that green. Without the 6, the 19 clue is even further restricted, I would say. You can still start with 2, 3, 4, or 5, but this can no longer start with an even number. Okay, this can't be 2 or 4. And if this is odd, then this number is certainly also odd. 1, 5, 7, 9. It's not a 1 because it's got a crescendo from the bottom here. And if it's 2 odds, then this digit is also odd. So we can actually mark odds in the entire sequence. And it's not going to be 5 odds. The same story we had up here. It's not going to be 5 odds. This is again going to be green. And notice that if this was a 5, this would have to be 3, 3 and 5. This number, in order for the Rossini constraint to be violated, with this being 5 and this being 3, whoops. With this being 5 and this being 3, this would absolutely have to be a 1. And then this even number, which I just uncolored, this even number would have to be a 10. So by that sort of, trickery, we can conclude, sorry. Come on, guys, wake up. This is this. All right. So with that sort of trickery, we can conclude that this number was 3 or 5. This number cannot be a 5. It's either 7 or 9. And this digit is definitely going to be smaller than 7 or 9. So it can be 1, 3, or 7. But if it's 7, this is 9, this is 3, we've already got 19, this would have to be a 0. So this can't be a 7. And also it can't be smaller than 6, of course. Okay. So I think, and I'm not sure, but I think that's as much as we can do with this box at the moment. We've got a 7-9 pair, which is interesting. 7, 9, 6, 8. But this can still be a 5 or it can be 4, I suppose, right? This digit is smaller than this one. Let's just pretend it's a thermometer. 2, 3, 4. This is 3, 4, or 5. And this is 1, 2, 3, or 4. And there might be some more eliminating you can do here. Oh wait, neither of these can be 3, I just realized, because of the column. But I don't see, I think that you can whittle away at this a little more to get to the end, but it's not very satisfying. At this point, actually, we do end up jumping to box 7. And then we'll bounce back again later. And here again, like in all of the outer boxes, I've got 3 Rossini clues here, 3 of them here. I originally had 3 of them here, but never mind. And I have 3 here. So this is a very busy intersection. This digit, you'll notice, is smaller than both of these, smaller than both of these. So it has a maximum of 5, right? 6, 7, 8, and 9. Yeah, this has a maximum of 5. It can't be 3 or 2. It can be 4 or it can be 1. All right. And notice that if it's 4, these 2 digits from the 19, they can't both be odd because you'd end up with an even number. They would have to both be even without using a 2. So this would be 8 and 6. And this would be 4, and this would have to be 1. Okay? But 8 and 6 are larger than 4, and these digits are also larger than 4. So this can't possibly work. Okay? With 6 and 8 here, this would have to be 5, 7, and 9 in these 4 digits, and that's just blowing the whole thing up. Okay, so this can't be a 4. Can it be a 5? Well, it's certainly odd, right? It's certainly an odd number, and it's creating, I think this is funny, it's creating a 1, 3, 5 triple with this digit, with those digits, which doesn't help us per se, but is kind of funny. And it's going to help us enormously if we can eliminate 5 from this square. In order to eliminate 5 from this square, we have to think about what's going on underneath it. Now, I think we can agree that these 2 numbers, in order to work with the 5 clue, they're going to have to be odd. Right? 5. I guess this could be 6 and 8. Ah, right. If this is 6 and 8, the 5 is smaller than both of those, and it's still smaller than all of these. So that's hopeless. In order for in order for this to actually work, these 2 have to both be smaller than 5, and they have to be odd. So this is 1 and 3. Again, all of these add up to less than 10. This even digit, which is definitely even, has to be 10, and that's not possible. So with that, we've eliminated 5 from this square. This has to be a 1. Whoops. Isn't that nice? Because that means this is now definitely a 3. This is definitely a 5. That makes 8. With a 7, it would be 15. With a 9, it would be 17. So this is either a 2 or 4. The 19 is definitely 2 odds. 2 odds with the 1 plus an even. And these 2 odds, they can't be 5 and 9, and they can't include a 3. So without 3, this is 5, 7, or 9. They can't be decrescendoing, so this can't be a 9. This can't be a 5, right? Yeah. This number, the middle number, is going to be the largest one in the series. And again, we have a 5, 7, 9 triple. Okay, now 2 is already taken in this row. So if this was 7 and 9, it would be 16 plus 1 is 17. This digit has to be a 2 then. So 7 and 9 is not possible. 7 and 7 is certainly not possible, so 7 is out. This is definitely a 5. If this was 5, 7, 1, this would be a 6, and if it's 5, 9, 1, this would be a 4. The 5 takes away the 5 from here, so this is now a 9. This is a 1, this is a 5. Okay. With the 1 in place, we're going to have a crescendo into both of these directions and a crescendo this way, which is cool. I think I've done everything in this box for now. This is a 7, of course, because the 9 is already in the column, so this is actually a 6. Okay. I can futz around with these a little bit more. Like if this is all crescendoing all over the place, one of these numbers is 2. I can't have a 3 here. The 3 would have to hide in one of these two squares, right? Well, this could also be a 3. But anyway, I'm going to stop because I can go back to this box again. And this number is a 4 for sure because I've already got the 5 in the box. We've got a 7, 9 pair. Neither of these is a 4, and this can't be a 3, so this is 2. This is 1. We have a 7, 9 pair that's unresolved, but that's not the end of the world. 5, 9, 3 would make this a 2. 5, 7, 3 would make this a 4. We've already been there. No new love in that department. These two numbers, what's left over? 1, 2, 3, 5, 6, 7. This is 4. The 4, unfortunately, can't be eliminated from here because I can still have like 1, 2, 4, or 1, 3, 4, or even 2, 3, 4. So, too bad. But with the 5 and 2 already taken here, then this reduces down to either being a 3, 4 pair. Can this be 3? Well, it can be 1, 2, and 3, 4, 7, 8, what have you. There's no restriction there, I don't think. Let's see. In this section, I have 2 7s. Yeah, there's a 1 and 7 in here. There's a 6 in this part of the grid. Can this be 6? 7, 8, or 6? Yeah, this would have to be 6, 7, and 9. 1, 7, 5. Oh no, 7's taken, 8 is taken. This can't be 6. But by Sudoku, one of these two digits has to be a 6. This won't work. This has to be a 6 now. And that's kind of cool because these two numbers have to be less than 6. They can't be 1 and 5. They can't be 4. So without 1, 5, and 4, this is 2, this is 3. And as you know, it's crescendoing. So what's left over here is 1, 7, and 9. We know this cannot be a 7, and it can't be a 9. This digit has to be a 1. So now we have a 7, 9 pair. And the rest of these digits, which again are crescendoing downward, 1, 2, 3, 5, 7, 6, 4, 8, 9. This is a 4. This is 8. This is 9. That resolves the 7, 9 in this box, and then this becomes a 2. These two digits, what's left over, are 8 and 7. Yeah. And now we have a 7, 8 pair here, but that doesn't do much for us. Let's fill in the rest of the candidates here. 1, 2, 5, 7, 8, 9, 3, 4, 6. 2, 4, 6, 3, 7, 8, 1, 5, 9. This can't be a 9. This can't be a 1. This can't be a 6. And I think that's all we have in terms of eliminations. 1, 5, 9. Yeah. Yeah. Okay. So it looks like all of the parity party clues are fulfilled. I don't think I'm missing any. So the rest of the puzzle is Rossini logic and Sudoku logic. The Rossini clue here, I know that this number is always less than this number, and this number can't be between them. 5 would automatically be between them, so this must be a 1. This cannot be a 1. Yeah. This increases, let's see, I don't know if that's helpful. Can this be a Can this be a 5? Yes, it can. 4, 5, 2, something like that. Oh no, it can't be 4, 5, 2, because that takes away both the 4. Oh, this 2 I just realized resolves this 3 and this 2, but that doesn't resolve anything else in the box. Let's highlight these just to be consistent. This is odd. Whoops. I just unselected it because that's how the UI punishes me. These three are all odd. I don't know if the parity argument, we don't really need parity anymore, and I'm maybe going to take away all the coloring rather than just leaving the grid half colored. Okay, so the rest of this is, as I say, crescendo logic or Sudoku logic. The numbers in here that are left over are 2, 3, and 5, right? 2, 3, 5. This digit's always going to be smaller than this one's always going to be larger. No love there. No true love here, at least. Can this be a 4? If this is 4, this would have to be 2 or 3. Yeah, 4, 2, 9 seems to work, but such is life sometimes. This can still be 1, 2, 3 or 1, 2, 4. Let's draw in the candidates. If this is 4, this would be 2. Actually, this can't be 3, can it? And it's smaller than this, so this is 2. Whoops, 2, and this is definitely 1. These two numbers are 8 and 9. There's always going to be a crescendo here, no way to avoid it. But these two numbers that are left over here, 1, 2, 3, 4, 6, 8, 9, 5, 7. This can't be a 7 because then I'd have a crescendo here, so this is 5. This is 7, and then everything is sort of doing fine. All right, let's finish up on this side. 1, 5, 8, 1, 3, 4. The 8s in these squares push an 8 into one of these two squares because we've already got a 7, 8 pair in here. 3, 4, 9, 7. Not quite sure what to do immediately next. Yeah, this is not a 3 anymore. So with this not being a 3, 6, 5, 2, 4, 5, 2, nope. None of that is terribly helpful. 7, 9, 2, 5, 5, 8. What did I do wrong here? This can't be a 1. Sorry, I'm going to go back a little bit. Why did I put a 1 there? This crescendo, I misread this. This cannot be a 1. This has to be a 5. My apologies. This is 9. This is 1, because this has to increase in this direction. Yeah, my profoundest apologies. So now this 2 resolving this 3. I had to back up a little bit. I apologize, and I'm done apologizing, just like that, with a snap of the fingers. This is not a 3. This is fine. This is fine Rossini-wise, and so is this. With the 5, I resolved with 4 and 5. That's probably what was preventing me from flourishing. There's an 8 at the bottom in these two squares. 7, 9, 6, 1. All right, I'm gonna pencil mark these in now with the benefit of foresight. The 3, 4 is less than 2 or 3, which is less than 1 or 2. This can't be 3, so it's forced to be 2. This is 1. The 2, 3, the 3, 4 here can't possibly be resolved yet, but what's left over here is 8 and 9. What's left over here is 7 and 5. But if I make this a 7, then I've got a steady crescendo, so this has to be a 5. This is a 7. Crescendo guaranteed there, and these two 8s are in place. 6, 7, 9. These 3 numbers are 2, 3, and 5. And 1, 2, 1, 2. There's a 1, 2 in this column, and they can't be here, so 1 and 2 are here. This is a 1. This is a 2. This can't be 2. This is actually already a 3 because I've resolved this 4 somehow. This is not a 3. So I've got a 4-6 pair here. All the Rossini stuff is kosher. This is a 7 or an 8. There's a 7, 8, 7, 9, small. Oh, this is not a 2, and this is not a 2. So this digit is a 2. And we've got a fine Rossini situation there. That's solid. 1, 2, 3, 5. 1, 2, 5, 6. Is there some weird make it single somewhere here? Don't see it. 7 and 8. These two digits are the same as this one. Let me just highlight them. And let's get rid of all the rest of the highlighting. Sorry. So these 3 are pinkish. What am I don't think you're supposed to get stuck here at this point. 5, 6, 8, 3, 7, 4, 9, 1, 3, 4, 1, 5, 8. This is 8. Oh, this can't be 7. Sorry, we've got a 7 here. But 7 is going to resolve this. My fault. Okay, bad scanning. 9, 7, 8, 9. This is 8 and 4. That makes this 3 and 4. And this is 8, 7, 8, 8, 7. This is not an 8 anymore, blah, blah, blah. 4, 6. This resolves the 3 and the 5. 1, 2, 4, 5, 6, 7, 8. This is 3 and 9. And that resolves because of what's in box 2. 1, 2, 3, 8, 9, 4, 5, 6, 7. 5s are out of here. This is a 5. That leaves a 6. That resolves the 4 and 6. And finally, this is a 4. This is a 7. And we're done. Okay, so despite my horrible scanning, I think I was able to convey the solve path for this one, and I hope it was helpful. And then I hope more than I could possibly deserve to hope that it was an enjoyable video to watch. Thanks for your patience.